Hello, Robert Wohlfahrt here, and today I want to show you a little tool that can help you really often to interconnect these single nifty tools you use at the command line. So you are working at the Linux command line and perhaps you're writing shell scripts. And from time to time you find yourself searching the internet for a solution to a problem you're faced with. And then from time to time you think, what the heck are they using xargs for? Okay, you copy the solution you have found, and if it works, you'll simply forget to think about this xarg thing. But now let's lighten up the darkness and let's understand what this xargs can be used for. If I had to say it with my most simple words, I would say something like xargs can be used to beam input lines to parameters. Let's start the explanation with an old Unix philosophy. Do one thing and do it well. This philosophy is a base paradigm of every Unix-like system, and therefore you will meet this philosophy also during your work at the Linux command line. Do one thing and do it well. This simply means most of the tools at the Linux command line are capable of serving only one single task, but they can serve this single task outstanding well. So okay, we are at the command line and we have tools that can serve one single task very well, but only one single task. But typically our problems are a little bit more complex, so we need to leverage multiple of these single commands. We need to combine multiple tools. That sounds obvious, but let's have a look. If we need to combine multiple tools, we typically use the data streams every command gives us. You may know that every command per default is equipped with 3 data streams. One for reading data in, the input data stream, std_in. A second data stream for printing out the normal messages to the console, the standard output or std_out. And for error messages, we have a third one, std_err, the standard error output. And if we want to combine two commands together, we typically use the vertical bar or the pipe sign to connect the standard output of the first command to the input data stream of the second one. This way, the second command can process the data that were produced from the first one. Here are 3 examples of command lines using this pattern. List all the files in etc and count them. List all running processes and search for a line containing Apache 2. And print out the disk space that is consumed by all files and sort this list by the used disk space. These are 3 examples, and I'm sure you already used such patterns many times before. These 3 commands, wc, grep and sort, have one thing in common. They are all capable of reading in its data from the input data stream. But there are other types of commands. There are commands that cannot read or that simply don't read from standard input. What about these commands? Let's talk about, for instance, the rm tool for removing files, or user add for creating a new user, or kill to terminate processes or sending signals to them. Or what about a copy command? These commands get its data simply via command line parameters. And this is the time where xargs comes into play. Xargs can be used to beam input lines to parameters. So if you have data as a data stream, here as the output from a command, and this data has to be processed as command line parameters of another command, then use xargs. Xargs takes the input data line by line and builds command lines with a given command. Let's have a look at 3 examples. Here, find searches for files within TMP that were not accessed within the last 30 days. And it prints out these lines line-wise on its output data stream. Xargs takes this data stream, builds a parameter from every line and calls the command rm with these parameters. In this way, rm could be called only one single time, for instance with a list of 100 parameters if find finds 100 files not accessed within the last 30 days. The second example takes the ps command and a sequence of grep commands to get a list of the process IDs from all running Apache 2 processes. xargs then reads in these process IDs line by line and calls kill-hup with the red in lines. These are all the single process IDs as additional parameters at the command line for kill. And third, again the find command. This time we are searching for files modified within the last 24 hours. And we use xargs to call copy to copy every single file we have found to the backup directory. These are 3 great examples for the usage of xargs. 3 commands that are capable of reading from standard input but use only command line parameters. RM, kill and copy. And we simply use xargs to beam lines from the input data stream to these command lines. So if you have your data within a data stream and you want to process this data with a comment that doesn't read from a data stream, then use xargs to beam the lines from the input data stream to the parameter list of this comment. Xargs followed by a comment reads in data line-wise and takes these lines as parameters that are appended to the given comment. If you want to limit the number of parameters a single command line gets, use the -L parameter followed by this number. If there are more input lines than your defined parameter limit, then the given command is simply called multiple times until all read-in lines are processed. And if you have a command line where you don't want to just append the parameters, but you want to insert them between other pre-written parameters, then you can specify a replacement string that can be used at the command line you give to xargs simply as placeholder for the parameter you want to include. Just like in the last example of the previous slide, where the copy command shall copy a file to a destination directory. The xargs command gives you really fine-grained control over how to compose and call the needed command line and also how to pre-process the data from the read-in data stream. If you need some more control than the patterns I showed you here, have a look into the manual page of xargs. I hope you enjoyed this short intro into xargs. See you next time. Robert.